This lesson is on the law of sines. I'm going to first of all show you a quick proof of the law of sines. Yesterday we did the area formula, so for triangle ABC, you can remember that the area formulas told us that 1/2 any two sides times the sine of the angle between them will give you the area. So this was one of them, AB sine C, 1/2 AC sine B, or 1/2 BC sine A. All of those give you the area of the triangle. If you were to take each one of these formulas, since there's an equal sign between them, and multiply all the way through by 2 over ABC, watch what happens to the formula. If I multiplied 1/2 AB sine C by 2 over ABC, and the other one by 2 over ABC, and ABC 2 over ABC, you'll notice that the 2's will cancel, and the AB will cancel with the AB, and you're going to be left with sine C from right here over side C. And here, when the 2's cancel and the AC cancels with the A and the C, you get sine B over side B. And here, when the 2's cancel and the BC cancels with the BC, you get sine A over side A. That is the law of sines. That's what we're going to use when we solve triangles now. Law of sines doesn't mean that B and C are equal. It means the ratio of the sine of an angle is to its side as the sine of any other angle in the triangle is to its side. So the ratios are the same, but that doesn't mean that the angles or the sides lengths have to be the same. Okay, so let's try to use the law of sines to solve a triangle. We're going to start off with a triangle that looks similar to this one in example 1. And we've got A to be 100 degrees, side B to be 50 meters, and angle C to be 25 degrees. I'm going to ask you, or they're going to ask you tonight, to solve the triangle, and that means find all the missing measures to the nearest tenth. So, first of all, we're going to find angle B by realizing that you have to have 180 degrees in a triangle. So you're going to take 180 degrees, subtract off the 100 that's already there, then subtract off the 25 that's already there, and you've got 55 degrees left for angle B up here. Now that we've got angle B, we needed B because we have the side opposite angle B. So we needed to get B so that we could use that ratio. Now we know the ratio using the law of sines of the sine of 55 is to 50, as the sine of 100 degrees is to A. So as the sine of 100 is to A. So the sine of B is to its related side, as the sine of A is to its related side. So when you work this out and solve it by doing cross products, so we're going to solve it on down, you're going to get 50 sine times the sine of 100 divided by the sine of 55 is approximately 60.1 meters. You can do the same thing to find the side C by doing the sine of 55, which is angle B up here, is to 50, as the sine of 25 is to side C. So this time we're going to be solving for side C. And when you work this out, you're going to do your cross products, and you're going to get 50 times the sine of 25 degrees divided by the sine of 55 degrees, and that's going to give you approximately 25.8 meters. So if you'll sit there and look at each one of the missing parts now, you've found all of the missing parts. So the missing parts of the triangle are angle B is 55 degrees, side A is 60.1 meters, and side C is 25.8 meters. So there's one way to solve a triangle using law of sines. Now I'm going to show you a little bit different when we're missing some other pieces. Okay, so in example 2 here, we have an angle of 126 degrees. We have two sides at 7 and 12, and I'm going to ask you to find theta and theta to the nearest tenth of a degree, and theta is the missing angle this time. So the first thing we're going to do is use law of sines. You can see that we have an angle and the side across from it, and we've got the missing angle and the side across from it. So using law of sines, you can set up your ratio that the sine of theta is to 126. The sine of theta is to 7 as the sine of 126 is to 12. Using cross products and dividing, you can find out that the sine of theta would have to be approximately 0.4719, and using inverse sine, get that the angle has to be 28.2 degrees. But now you've got to remember, our old trig tells us that when you're looking at the circle, the unit circle, there are two places in which the sine or the y value is 0.47, and that's at 28.2 degrees and also at 151.8 degrees. When you can get the 151.8 by subtracting the 28.2 from 180. So either one of those are possibilities. So you go back up to the circle and you look, can both of them fit into the triangle? 28 fits in there fine. When you add it to 126, there's room for 180 degrees. However, if you plug in 151, it becomes too large to fit in the triangle with 126 degrees. So you can reject the 151 degrees because it's too big to fit into this particular spot. So theta has to be 28.2 degrees. The last example that I want to give you is one in which the angle could be two different options. You could have what's called an ambiguous case. If you have triangle PQR and you have a 48 degree angle at P and side P is 9, and you have a side R to be 10, and they ask you to find angle R. We're going to go through the same process we just did using the law of sines. Do your cross products and divide, and you will get that R is, using inverse, 55.6 degrees, and when you subtract it from 180, it can be 124.3 degrees. Now the question is, can angle R fit either one of those options in there? If you look at it with the 55.6 degrees in there for angle R, you've still got the larger side across from the bigger angle, smaller side across from the smaller angle. It's 55.6. You can add them up and get angle Q to be 76.4. There's still room for 180 degrees in there. So obviously 55.6 works. The question is, does 124.3 work? So when we look at that one, you can now say, can I put 124.3 degrees in there, still have side P be 9, side R be 10? Yep, the longer side is still across from the bigger angle, smaller side is still across from the smaller angle. There's still barely room for angle Q. When you add those two together and subtract from 180, we could possibly get a 7.7 degree angle. So this time, either angle could work. We don't know which one it is. It's called the ambiguous case because there's not enough information to determine a single triangle. It could be either one of those. So angle R could be 55.6 or 124.3. If this is the case on the homework and I ask you to solve the whole triangle, you're now going to have to use both of those to find two different answers for angle Q, and use both of those to find two different values for side Q as well. All right, you guys are ready to start your homework. Okay, now let's see if I can stop this. Okay, so